yo, Algebrainiacs. Welcome to the Johnson-Kendro video hour, minus Kendro. Remember, she's here in spirit. All right, we are going to finish up section 5.5. So this is the part 2 video from section 5.5. We're going to learn the next theorem. It is called the conjugate root theorem. And remember when we learned about imaginary numbers when we were dividing them? For instance, if we were given 5 plus I divided by 2 minus I, we used a conjugate of the denominator, 2 plus I, to get that denominator to cancel. So the conjugate always has an opposite sign on whatever you're trying to get to cancel. So when we did imaginary numbers, we changed the middle sign because we wanted the imaginary numbers to cancel. We're going to be using that for imaginary roots and also complex roots here. So they might have a radical in them. So here's what conjugate root theorem says. It says if a plus the square root of b is a root, then we know also that a minus, again changing that middle sign, square root of b is also a root. Same thing for imaginary numbers. A plus bi is a root, then we know that a minus bi is a root. So here's an example. It says a quartic. Quartic should be a big clue that that's an x to the 4th polynomial. Therefore, there should be 4 roots total. So a quartic polynomial has the roots square root of 2 and then 1 plus I. They want us to find the other roots. Well, remember, we have to have a total of 4. Here is the first one. It is just positive square root of 2. We need to change the sign on the radical, so the next one would be negative square root of 2. Make sure you put that negative on the outside of the radical, not on the inside. They give us the next root as 1 plus I. Therefore, we know automatically that 1 minus I is a root. Some of your problems are as simple as that, using the conjugate theorem to come up with other possible roots. But that's not all we're doing. We are going to use that theorem, use the conjugate root theorem, to come up with the polynomial equation. And we will want it in standard form, which means it will be FOILed out. This one says, find the polynomial of 3rd degree with the roots 4 and 2i. And then there's a little hint there. It says there's another root. What's it going to be? Okay, so this conjugate root theorem, I'm going to go back for a second. I want to point out that it only applies to things that are complex, meaning have a root in them, or imaginary, meaning have an I in them. So when you're looking at this root that is given, negative 4, that is not complex, and it is not imaginary. So we are not going to come up with a conjugate of that. Okay? When we look at this root, positive 2i, we know that it is imaginary, therefore there will be another one. So here's the first root, here is the second root. We need to come up with a third one. We're going to use negative 2i. Also, big hint here, 3rd degree polynomial, that means that there should be 3 roots total. So 3 roots, I've got those, but we want to come up with the equation. So I'm going to set it up in factored form. When you do factored form, you're going to change those signs of the root. So this one would be x plus 4 to take care of this one, because it's technically x minus minus 4. And then next one to take care of root number 2, that's going to be x minus 2i. And the third one will be x plus 2i. That takes care of all 3 of the roots. So that's step 1. Next, we want it in standard form, so that means we're going to FOIL or distribute to get our final answer. When you FOIL, I'm going to suggest that you FOIL your like things together. So here I'm going to put my 2 imaginary sets of parentheses together first before I deal with x plus 4. So I'm going to just rewrite x plus 4 to start. Here I go to FOIL. X times x, that will be x squared. X times 2i, that's 2ix or 2xi. Inner times inner, that's going to be minus 2xi. And then last times last, we have a positive 2 times a negative 2. That's going to be a negative 4. And then we have I times I, which is I squared. And then if you think back to our lesson on imaginary numbers, we learned that I squared is equal to negative 1. So anytime you come up with that, like we did here, that's going to change the sign on that coefficient. So that will actually turn to positive 4. Also, I want to simplify before I FOIL in the next step. I'm looking at the middle 2 terms here. Those are like terms because they both have an xi in them, and those are opposites, so they're going to cancel out. So let me rewrite here. I've got x plus 4, And then now this, what was a complicated set of parentheses, is very simple. It's just x squared plus 4, because that's all that's left. Still need to FOIL here. Going to do x times x squared, that's x to the third. X times 4, that's 4x. Inner times inner is going to be 4x squared. And then 4 times 4 is 16. I want to make sure I have a standard form, which means combine your like terms. Also put the exponents in order. So x to the third should go first, then 4x squared, then 4x, then 16. Also, at the very end, you should double check. We were supposed to come up with a third degree polynomial, and therefore my final answer should be x to the third power. Here's the next example. It says try it with the roots 2 minus 3i, and then 8 and 2. This is the only root that is imaginary or complex, so that is the only one that's going to have a conjugate, 2 plus 3i. So I've got 1, 2, 3, 4 roots total. Therefore, I'm going to have a fourth degree polynomial. Let's talk about the real numbers first. So x minus 8 is going to be one of them, and x minus 2. And then when we do the imaginary numbers, now I have binomials. So we need to be very careful when we set this up. Here's how you're going to do it. You're going to make a bracket, and you're always going to write x minus, no matter what. Then within that bracket, you need to write those imaginary numbers. So the first one is 2 minus 3i. Close the parentheses, close the bracket. And then I'm going to do it again. X minus, it's always going to say x minus. And then in the parentheses, this one will be 2 plus I. Close parentheses, close bracket. I want to get rid of these parentheses within the parentheses. So first thing to do is distribute the negative 1. We're not distributing x, just distributing the negative 1. That will turn this to x minus 2 plus 3i. And on this one, same thing, distributing the minus 1. That's going to be x minus 2. Whoops, I forgot my 3. This was supposed to have a 3 on it. X minus 2 minus 3i. Also, this is a good time to check your work. You should have exactly the same thing in the first place. In the second place, the only thing that should be different is the sign on the very last term there. So that's a good thing to check before you move on. All right, I am going to FOIL these two guys together to write them down in my next step here. X times x is going to be x squared. Then we'll have a minus 2x minus 8x. And this one will be plus 16. And I'm going to combine like terms in the middle. X squared minus 10x plus 16. So now I've taken care of these two. And I'm going to have to FOIL my green sets of parentheses together as well, which will be a little more complicated. So let's do that next. X times x, x squared. X times minus 2, minus 2x. X times negative 3i, that's minus 3ix. Then I'm bringing my minus 2 over. Minus 2 times x is minus 2x. Minus 2 times minus 2 is plus 4. Minus 2 times negative 3i, that's going to be plus 6i. Okay, last one, we're going to take this plus 3i over, so plus 3ix. Then we will have 3i times the minus 2. That's going to be minus 6i. And then lastly, it's a positive 3i times a negative 3i. That's going to be a negative 9i squared. And hopefully you remember that I squared is equal to negative 1, which is going to change this whole term to plus 9. Whew, very complicated. But you will see that it will not stay complicated. If you did your FOILing correctly, you should get all those weird terms to cancel out. So I'm going to combine like terms next. Let me switch colors here. X squared, that's the only one of those. So I'm going to write that down and then I'm going to cross it off my list. Next in line, I've got minus 2x and minus 2x. I can put those together, minus 4x, cross them off. Next is minus 3ix. Later on, I've got a plus 3ix, so those are going to cancel, which is great. Next in line is my positive 4. I'm going to combine that with my positive 9 here, so plus 13. And then I'm going to cross them off my list. Last, I have positive 6i, but you should have a negative 6i. So when you FOIL out your two imaginary sets of parentheses or complex sets of parentheses, you should get all of those weird terms to cancel out that contain your i's. If you didn't, you made a mistake, and I would not move on any further. I'd go find that mistake. All right, last thing I need to do is put these two trinomials together. So I'm using distributing. X squared times x squared is x to the 4th X squared times minus 4x is minus 4x to the third. X squared times 13 is going to be 13x squared. Now I'm moving on to the middle term here. Minus 10x times x squared is minus 10x to the third. Minus 10x times minus 4x is going to be positive 40, and this one's x squared. Minus 10x times the 13 is going to be minus 130x. Last one, taking 16 over. 16 times x squared is going to be 16x squared. 16 times the negative 4, that's negative 64x. And then I've got to do 16 times 13, and this is when I need Mrs. Kendro to do the calculator for me, but she's not here. That is, let's see, 208. All right, last thing to do is combine like terms. So you got to find your like terms. X to the fourth, that's the only one of those. Cross it off. Then I have my x to the third. So a minus 4x to the third and a minus 10x, that's minus 14. X to the third power. X squareds, I have a 13 positive. I have a 40 positive, and then I should have one more. There's my 16, which is 69x to the second. I'm going to cross all those off my list so I can keep track here. I have a minus 130x and a minus 64x to put together. That's going to be minus 194. X. And then just my constant, 208. We should have a fourth degree polynomial because we had 4 roots total. Okay, so it's quartic. Last example here, so I wanted to do one that has a radical and not just imaginary number. So it says try it with the root, square root of 5. That is, it either has to be imaginary or a complex number containing a root to have a conjugate. This definitely does contain a root, so therefore we have another one. It will be minus the square root of 5. So just 2 roots here. That means we should have a quadratic equation at the very end. When we set it up, we need to do x minus the root. So x minus root 5, and then the other one will be x plus root 5. I did not need the brackets because these are not binomials. It's just one single term. I'm going to FOIL. X times x is x to the second. X times root 5, we haven't talked much about radicals, but I'll give you the short version here. Things outside of radicals can be multiplied by other things outside, and then things inside can be multiplied together. So if you notice, x is not in the radical, but the root 5 is. So that would just be x on the outside with root 5. Next one, inner times inner, very similar. That's going to be a minus x root 5. And then last times last, it's a positive times a negative, so it will be negative. And then this will have a root. These are both under radicals, so you would multiply your 5 and 5 together and get root 25. Next, I want to combine like terms. My middle terms are opposites. That's the whole point of conjugates, is to get those things to cancel. So that would leave me with x squared. And then, similar to our I squared, something should happen in your last term to make that radical go away. And if you think about it, we have a square root of a perfect square. We know the square root of 25, it's just 5. So this would be the quadratic expression or the quadratic polynomial that represents those roots. All right, guys, I think that's going to do it for conjugate root theorem, and we'll see you in class.